Hey ladies and gentlemen, this is Miss Humbert here, and today we're going to be doing Unit 6, Notes 3. So we are going to talk about exponential growth, which is a specific type of exponential functions. So today not only are we going to be graphing them and writing them, but we're also going to be doing some word problems with them. And I will tell you that of all the units, these tend to be students' most favorite word problems. So you have that to look forward to. So exponential growth is represented by y is equal to c times the quantity 1 plus r to the t. C is going to be the initial amount of money that you spend. R is going to be the rate of change. Now you want to make sure you express that as a fraction or a decimal. Do not put a percent in there. You need to convert the percent. And then t is going to represent time. Okay, so I also want you guys to remember that our c value is going to be our y-intercept. So c value is representing that starting point, which also is going to be the y-intercept of anything that we graph. So let's go ahead and let's practice graphing some exponential growth equations. So to write the equation, we're going to have y equals, and then we're going to take our starting amount, which is 8, times 1 plus 0.45 to the x. Okay, now you could go and simplify this down. I won't take off points if you don't, but for me, I just like it as simplified as possible because that's just one less button I have to press on my calculator. So this right here is the equation that we're going to graph. So we're going to set it up the same as we did before. We had 0, 1, 2, 3, 4, and 5. So now we're going to plug each of those values into our x. So we're going to do 8 times 1.45 raised to the 0 power. Well, that's just going to be 8. So 8 is our c and 8 is our y-intercept. Good, we did that right. Then 8 times 1.5 to the first is going to be 11.6. And then 8 times 1.45 squared is going to give me 16.82. There's a point between there. I wrote those two really close together. And then 8 times 1.45 to the third, you get 24.39. And then 8 times 1.45 to the fourth, and I get 35.36. And then for the fifth, I get 51.28. Okay, so now we can go ahead and graph it. So here we're going over 0 and then up 8. Then we're going over 1 up 11.6. So that's going to be a little over halfway to 12. Over 2 up 16.87. So that's going to be almost 17. And then the rest of them are going to be off our graph. So we're just going to go ahead and connect those, and that's it. So that's going to be our graph for number 1. Now, when you're doing exponential growth, your graph should always be going up, okay? You shouldn't be sloping down. If you're sloping down when you do exponential growth, then you did something wrong, okay? Let's take an example of another one of these. So what we're going to do here is we're going to write out the growth equation. So we have y is equal to 6 times 1 plus a third, which I'm actually just going to write as 1 plus 0.33. Now, if you change a fraction into a decimal, please make sure that you are careful of your rounding. So then what we end up getting here is y is equal to 6 times 1.33 to the x power. So then I'm going to have 0, 1, 2, 3, 4, and 5. So now I can go ahead and plug that in. So I'm going to have 6 times 1.33 to the 0 power. Well, that's just going to give me 6. Then I'm going to have 6 times 1.33 to the first power. That's going to be 7.98, or basically 8, okay? 6 times 1.33 to the second power is going to give me 10.61. 6 times 1.33 to the third, that's going to give me 14.22. Okay, 6 times 1.33 to the fourth is going to give me 18.77. Again, always a good idea to be checking this with me to make sure you're plugging it in correctly. 6 times 1.33 to the fifth is 22.28. So then we're going over 0, up 6, so we're crossing the y-axis here. Then we're going over 1, up 7.98, which basically is 8. and that's only not 8 because of our rounding. So then over 2, up 10.61, so it's just about 2/3 of the way to 11. Over 3, up 14.22, so that's going to be just past 14. And then for number 4, 18.77, that's going to be really close to 19. So it's going to be sloping up that way. And then our 5th one is going to be off the graph. Again, they're always going upwards. Okay, so next let's take a look at number 3. So this is a word problem. Okay, so in 1971 there were 294,105 females in high school sports. Why was that such a hard number to say? I don't know. Since then the number has increased at an average of 8.5% per year. Whenever you see a percent, you want to convert it into a decimal. So that means you're going to take the decimal point and move it left 2 places. So then here I get 0.8085. I don't care if it's 0.002%. If there is a percent symbol after that number, you have got to convert it into a decimal. It doesn't matter how small of a percentage it is. So then what we're going to do is we're going to write an equation. So the number of girls is equal to our starting value, which is 294,105 times 1 plus 0.085 raised to the x power. Again, you could add these together to be 1.085, which would be the simplified way of writing it, okay? So according to the equation, you wrote how many females participate in sports in 2005. So what we're going to do is we're going to erase our exponent. What we need to do is figure out how many years passed between 1971 and 2005. So to do that, the easiest way for me is just to take 2005 minus 1971. And when I do that, I end up getting 34 years. So that's going to be the exponent that I plug in here to solve part B. So then at my calculator, I'm going to do 294,105 times 1 plus 0.085 to the 34th power. And that's going to be 4,711,004 females. Okay, so that's your final answer for number 3. Now, let's take a look at number 4. It says in the city of Farmington, the population was 21,087 and had a growth rate of 1.9%. So again, we want to make sure we convert that into a decimal. Like so. So then, our initial value is 21,087 times 1.019, because that's the same as 1 plus 0.019. I'm just kind of skipping a step there, but that means the same thing. And then we're going to raise that to the x power. So then it wants us to figure out what the population would be in 2013 and in 2017. So we need to go through and change that exponent. So we need to figure out how many years passed between 2010 and 2013. Well, that's just going to be 3 years. So for 2013, we're just going to use an exponent of 3. Now, when we're talking about people, you do need to round to the nearest person. You don't want to say that there is 0.9 of a person because that's unkind, okay? So make sure you're rounding it to the nearest person and make sure that you're careful of your rounding because you will get that wrong on a quiz. So go ahead and type that in your calculator and see what you get. When I did it, I got 22,312 people. Again, word problem labels are good, and that's for 2013. Okay, so then let's go ahead and take a look at 2017. So in 2017, then 7 years have gone by since 2010. So then in my calculator, I'm doing 21,087 times 1.019 to the 7th power. And when I do that, I get 24,057, and that's going to be people, and that's going to represent 2017. Okay, so again, it's really important that you watch your rounding on these type of problems. So now let's go ahead and let's take a look at number 3. So for number 5, sorry, I don't know where I got number 3. From number 5, it says the initial population of 750 endangered turtles triples every year. Well, triples just means 3. So what I'm going to have is y is equal to 750 times, since triples means 3, that's going to be my rate of change, okay? I don't need to do 1 plus that. I can just put in 3 raised to the x power. So now I want to determine the population after 8 years. So for this part B, I'm going to take out the x and I'm going to put in 8 years. So I'm going to have 750 times 3 to the 8th power. So that's going to give me 4,920,750 turtles. That makes me happy because turtles are pretty and I like them. All right, so that's your final answer for part B, and that concludes your exponential growth video. Thanks for listening.